So we saw last time that if we have a terminal alkyne, we add some sulfuric acid, some water, some mercury sulfate, we'll end up with a ketone. But is there any way we can end up with an aldehyde? And the answer is yes. And so if you think back to the alkene chapter, how did we add an OH in an anti-Markovnikov fashion? Well, we use our borohydration oxidation. So that's the same thing that we're going to do here. So at first, that will form this enol product. Right now, you see we've added our alcohol on the less substituted carbon. However, this is relatively unstable, and so it'll undergo tautomerization quite quickly. However, this time we don't have an acid. Instead, we have a base, right? Because we've got sodium hydroxide floating around. And so we'll deprotonate this oxygen. And then this oxygen will add down to this double bond, or to this carbon that's already double bound, and so we don't want to break the octet rule. So then our double bond carbon just goes ahead and picks up an H from a nearby water molecule to give us our aldehyde at the end. And so you can see you'll never end up with an enol. It will always tautomerize either to an aldehyde or a ketone. But we have good control, again, over alkynes. So if we have an alkyne, we can choose to form a ketone with this if we use our acidic conditions and our mercury sulfate, or we can form an aldehyde instead if we use our borohydration oxidation step instead. And so you can see you've got a lot of choices with alkynes.